Since this is the flag help video for the second portion of your review packet, units 7 and 8, that would be circles, areas, and solids. So on this page right here, the first one we're going to do together is problem number 6. And it says, find the circumference of each circle. Use your calculator's value of pi. Round your answer to the nearest tenth. So we ask ourselves, what do we have and what do we need? We have the area. So we have been given the area. So step number 1 is you actually write the equation of an area, which is apple pie is really, really good. And we want the circumference, which is C, d pi, I, C, d pi. So that's what we want. You always just ask yourself, what do you have? We have area. So that means 227 equals pi r squared. Now our goal obviously is to solve for the radius. Once we solve for this radius, we just double it and get the diameter and we are good to go. Got to remember here, the only variable you actually have here is the radius. So we're going to start by dividing by pi to get that pi itself. And it says use your calculator's value of pi. So that means we're going to go 227 and divide it by pi. So 227 divided by your pi key. And go ahead and take your answer to the second decimal place. So that's 72.26. 72.26. So that's 72.26, and that's your r squared. Now to undo a square, you square root. You're going to do your own math there. You're going to square root. You find your own radius, whatever it is. And then to get your diameter, you obviously take the radius and you times by 2. That gets you your diameter. And then you plug it in there. And then times by your pi key again, because the answer key is keyed to the calculator's pi key. So you're going to finish that on your own. All right, so you finish that one on your own, do your own math, and then check your work in the back. Okay, number 7 and 8 says, find the length of the arc. Notice that word, it's length. It is not measure. So the length of the arc here is going all the way around. Now the arc's measure is really easy. Measure of a central angle to its arc the same. So the measure is 315 degrees. That is not the same as arc length. Arc length is simply a piece of the circumference. So that's the fraction, theta over 360, times the circumference, which is d pi. So take a look here. We're going to do arc length. Equals 315 over 360, and our diameter here is going to be times 12, you always trace it, pi. Alrighty, from here you just start hacking away at what you can. And I know 12 goes into 360. 12 goes into 36 3 times and is 0, so that's going to be a 30. And then you start just hacking away here. I know 5 is going to go into both of these. So 5 goes in there 6 times. I'm going to go 315 and divide by 5. So that's going to be 63. So I have 63 over 6 pi, and I'm pretty sure 3 goes into both. It does. So 3 goes in here twice. 3 goes in there 21 times. So your final answer, if you hack it all the way down for arc length is going to be 21 pi over 2. Check for units, and it's yards. Sector area is just a fraction of the area. Okay. It says find a measure of the arc or central angle indicated. Assume lines that appear to be diameters are actually diameters. So check number 1 is to check for diameters. And if you have any diameters, you always trace and stretch those out. Taking a look at number 12, there are no diameters. We are specifically being asked to find JGI. Go exactly in that order. Start at J, go through G, all the way to I. So our goal is to find all those measures, and let's look at what we have. We have 35 there, we have 40 here, we have 160. So you need to find this blue, and that's the only thing you don't have. So you just add it all up and take it away, and once you find the blue, then you're going to find the red from here all the way around right to there. Number 14, it says find the length of the segment indicated, round your answer to the nearest tenth. Okay, let's identify exactly in 14 what you're looking for. We're looking for this X. I'm going to squiggle it in green for you. Now let's see. When you don't know what to do, the thing you always want to look for is a triangle. And if you don't have a triangle, your job is to make one. And what you need to remember in circles is all radii are equal. So that 10.5, I can swing it around right here. Or actually, I'm going to swing it on right there. And that's all now 10.5. Why did I do that? Because now I have a lovely right triangle, which is always a good thing. So this is a right triangle. So let's always find what we can find. Okay, we can't find X yet, but we could easily find this side right here. I'm going to call that Y. Because we have a right triangle. So we can go, let's label it. That's a leg, this is hypo. So we can go leg squared plus leg squared equals hypo squared. Let's pull our numbers in here. That one leg is going to be 9.2 squared plus our other leg, which we're using pink, that's y squared, equals our hypo, which is 10.5 squared. Now, you need to find y by yourself. Take it to the tens place. Now, you're not done because you're ultimately looking for x. The trick here is the fact that this 10.5 is the same going this way. That's 10.5 because it's the same this way. Can you feel it? Center to edge. So once you find the pink, you already know the blue. Just find the green yourself. All right, let's take a look at our next one. That was 14. Our next one is 18. Let's take a look at 18. It says, find the angle measured, assume the lines that appear to be tangent are tangent. Things you want to watch out here for, a couple things. Remember to watch out for isosceles triangles, because where you have two equal sides, you have two equal angles. Next thing you want to watch out for, most importantly, is that when you have a tangent to a radius. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. And also don't overlook the simple stuff. All triangles add up to 180. So those are the things you want to be hunting for. So let's see what we have here that we can do of these three things. Number one, it says find the angle measure indicated. I always get in the habit, just find everything, and then, so be thinking that way. Don't be thinking in a limited way. Don't stare at that question mark and mesmerize yourself. How do I find just that? Don't let your brain get stuck there. So let's look at what you can find. We have a tangent, and that's a radius. So tangent to a radius, right angle at the edge. Next thing you want to look at is exactly how many triangles do you see here? You see one there, but let's not overlook the larger triangles. Because if you look at that larger triangle, now you can start getting stuff. This is 49. This is 90. You should be able to get this little toe angle out there. And you should have gotten 41. So far we've used this basic concept. We used tangent to a radius, right angle at the edge. We've used triangles add up to 180. Now let's see what else we can do. We have two radii. Let's trace them. Center to edge, center to edge. So this is a great one. We actually have all three things going on here. We have an isosceles because it is all radii are equal. So if that's 41, that means over here is 41. I'm going to let you finish this on your own. Right there is what our ultimate goal was. Right there. So when you work through these problems, what do you want to watch out for? Isosceles, tangent to a radius, right angle at the edge, and the fact that triangles add up to 180. So you find that little orange angle all by yourself. Good? Yeah. Okay. That's 18. Let's see. 19 and 21. Okay. Before I do 21, let's do a recap of all the different angles that we have. And we have space right here, so let's do that here. Ready? That's a central angle. Inscribed. Tan chord. Chord chord. Secant, secant. Tangent, secant. Tan, tan. There's your 7 angles right there. 7 angles. If you don't know these, they're also in your reference booklets, but you might as well write them out because you need to memorize them anyways. I'm going to sing the song really slowly. Ready? Measure of a central angle to its arc the same. So angle equals arc. Smaller angle of inscribed is half the arc, it's plane. Tan chord angle is the same as the one inscribed. A chord angles half the sum. of the arcs it strides. Secant, secant, tangent, secant, tangent, tan angles, that should be tangent, are all the difference of their arcs multiplied by half. So this one is, this last one, all three of them, remember they're out, all three of these are angle equals big arc minus little arc over 2. And anytime that word is out. So you need to have those memorized. Really, really critical. So taking a look at 21, we identify which one of these guys it is. Take a look. Notice this is out. So this is a tangent and a secant. So we write it out. So a secant tangent angle. That angle right there is going to be big R minus little r over 2. Now, so you always write the equations down. Even if you know them, you always write them down. Now we very carefully circle plug tug. We have the angle. We circle the angle. We plug it in. Please be in the habit of actually circling stuff. It helps your brain pick up the right stuff. Arc, circle, 75. 75 or 175? 175. Minus the little arc, which we don't know. That's your question mark. We'll call it X over 2. Ready? You're going to do your own math and check your work there. So pause the video, finish it up. Okay, 28 says use the information provided to write an equation of a circle. So the main thing here is to write the equation of a circle. So let's remind ourselves of what that actually is. And that's going to be x minus h parentheses squared, y minus k parentheses squared equals radius squared. So the first thing you want to do is actually write that equation out. Now let's look at what we already have. We have our h. We're going to be plugging in 9 right there. And we have our k. We're plugging in 2 right there. Problem is we don't exactly have a radius. Let's look at what we do have. We do, however, have circumference. Let's write that out. Circumference equals 10 pi. Now right underneath, write circumference equals d pi. Okay, from here, you're going to find the diameter, obviously. So find your diameter, and from your diameter, you're going to find your radius and plunk it in and bring your equation around all of these and do any cleanup you need to and finish that up. Okay, taking a look at this one, it says find the volume of each figure, round your answers to the nearest hundredth. Well, there's 2 equations we learned for volume. Let's write both those out here in the margin, just so you have them. For prisms and cylinders, that's going to be area of the base times the height. For pyramids and cones, because it's 3 dimensions, you're coming to a point, that's going to be area of the base times the height over 3. So we want to find the volume. So you start by identifying which one this is. And in 32, we have ourselves a prism. So we're going to write out our equation here, which is area of the base times the height. Always, 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 always shade your bases. So we're going to shade our bases here. Let me recap. In a prism, the bases have CPR. The bases have CPR, CPR. They are congruent. There's two of them. They're congruent. They are parallel. And they're connected by rectangles. So I can see that these two right here, this one and this one, they're congruent to each other. They're two triangles. They're parallel and they're connected by rectangles. So first I want to define my B here. My B here is a right triangle. So I write out that's going to be leg times leg over 2. Remember that B could change. If it's a trapezoid, it's a different shape. If it's a circle, it's a different shape. Height, distance between the bases. Now I start working circle, plug, chuck. Ready? Circle, plug, chuck. Leg, leg, 6. The other leg, 8. Over 2 times the distance between the bases, 11. And that's going to give us volume. You want to finish that on your own. A word to the wise, always, always, always shade your base, shade your base, shade your base. And then identify what your base consists of. Okay, so this one, it says find surface area. So now we're doing surface area of each figure. Round your answer to the nearest tenth. So let's recap what surface area is. For prisms and cylinders, surface area is circumference times the height plus the area of two bases. For pyramids and cones, that's circumference times the slant height over 2 plus 1 base. And remember that B, once again, let me emphasize, that means area of. Area of. So now this one's all about area. Remember, you don't have to use equations for area, surface area. You could also make a net. In fact, I'm going to do that both ways for the one that we're looking at here. Okay, let me show you both. So this one is a cone. So that's going to be CL over 2 plus 1 base. The net's going to look like this. If you peel it off, the base is a circle. And if you slice this down the side and unwrap it, it's going to look kind of like a strange looking triangle-ish with a curved edge. That's going to be a cone. So our goal is to find the surface area. Let's start with the easy stuff, this base. Base is a circle. So right underneath base, we write our equation. That's going to be pi r squared. Physically trace your radius. Don't use your eyeballs. Your radius is 4. So that base is going to be 16 pi. Now for the other one, it's circumference times slant height over 2. Our circumference is that edge right there, which is the same as this edge. We're going to write our equation for circumference, which is d pi. Physically trace your diameter, that's 16 pi. Times our slant height, which is that edge right there down the slanted. We actually have it. And that's going to be 8.9 over 2. I'm going to do this in pi form. So let me show you what that looks like in pi form. We're going to go 16 times 8.9, and then divide by 2. So I get this whole area is going to be 71.2. This is 71.2 pi plus 16 pi. Now you want to find the total surface area there and then check your answers. If your answer so you just wrap that up there. So a good way to do surface area is to do a net plus the equation. That way you know that you've taken care of everything. Okay, students, let's backtrack on that. I checked the answers. We did a real simple, or I did a real simple mistake, so sorry there, because I did not physically trace my diameter. Remember, that's d pi. Now, word to the wise, watch, even when the teacher doesn't trace, she got something wrong. That 8, I caught that as the radius. It ain't the radius, my friends. That 8 is the diameter. So we need to backtrack and change that, and change that. So that is an 8. Okay, so now we're going to come right here, and we're going to go 8 times 8.9 and divide by 2. Or technically we could do 4 times 8.9, same thing. So 8.9 times 4, we get 35.6. That is the striped area. Let me double check that. Yes, 35.6. 35.6. And then we add the 16. So all we need to do to add this up, this is like saying 35.6x plus 16x. That doesn't actually become 2x. This is going to be 0.61 carry 51, and that would be read 51.6x. So this over here is going to read 51.6 pi. We check units. Were we given units? Yes, and it's feet squared.